Hello, this is a video recording for AI Camp. It consists of two parts. I will first begin with my introduction. My name is Harsh Sanjay Agrawal. I am a graduate student at Stevens Institute of Technology. I am majoring in computer science with a graduate certificate in machine learning. I have been studying machine learning for the past 5 years of my graduate and undergraduate education, working mainly in Python and RStudio. I have worked on several projects with supervised systems like computer vision models, attrition prediction, recurring graphs, and I've also worked on unsupervised systems like the recommendation system. I have designed reinforcement learning pods to play video games. With this vast understanding of concepts of data and machine learning, I am confident that I will be an asset to your organization regardless of the technology stack being used. I enjoy being challenged and engaging with projects that require me to work outside of my comfort and knowledge set, as continuing to learn new latest trendy language and algorithm updates are important to me and the success of the organization. A few things that I would like to highlight from my skill set, which would be well suited for the situation, are I am proficient in deep learning, data mining, statistics, and calculus, and due to having the need to learn deployment, I learned software development in web programming and Android development using Android Studio. I have a thorough understanding of data structures and algorithms in C++, Java, and Python, and I'm also knowledgeable about data science development practices. During development, and by the virtue of working in technical undergraduate teams like the IEEE, CodeChef, and uh, Google Developer Student Club, I have extensive work experience on the Amazon Web Services and the Google Cloud Platform. I also have a well maintained project record with self written documentation and upgrades on GitHub. I have worked as a mentor and in lead positions several times throughout my undergraduate education. I worked as a technical mentor at the IEEE student branch of ISIES Graduate School of Technology. I was the Google Developer Student Club lead and the machine learning facilitator at my college, where we worked on multiple projects, developed new platforms, collaborated with Google experts on workshops, and much more. Having mentored and taught over 200 students, I take pride in my ability to teach difficult concepts with relative ease and have a proven track record of the same. Now, on to part 2. Let's talk about backpropagation. It is a machine learning algorithm which tries to mimic the human brain. It tries to make the machine learn new things, how we human learn things, which is by trial and error. For example, let's say a task is to touch a pan which is hot. The input would be touching the pan, and getting burnt would be the output. But what now? What happens now is that the brain rewires itself to not touch a hot pan again. It learns the fact that touching a hot pan is undesirable, the keyword here being learns. The rewiring or learning that just happened is what we call backpropagation, where we perform the task or the input. We compared the output of the task with the desirable output and then learnt any changes that were needed to get the desirable output. This was a very simple case where only two possible outcomes of getting burnt or not getting burnt were possible, and the result being desirable was pretty obvious. Not all tasks will be that simple. So let's talk about a slightly more complicated task. How about recognizing a handwritten number? We will consider a machine as a young child who's just learning new numbers. So, how does a brain recognize handwritten numbers? We see their shape, the style of writing, and at times we even look at the context. Context here meaning if a person tells us that a character he has written is a number, we would probably read it slightly differently. For example, the number 5 is often confused with the character S. So, for example, if someone tells me that they have written a number, I probably wouldn't assume it's the letter S. I would automatically say it's the number 5. So, context matters as well. So now there are multiple things that matters. Shape can also be easily misread in the early years. If the notch in the number 6 is drawn a bit smaller by mistake or due to a normal handwriting trait, it can be easily misread as a 0. Same with the 7 and 1. This is learned by practice and by repeating the task over and over again, improving our brain ever so slightly every time. This improvement is where backpropagation comes into play. We would give the child, or in our case, the machine learning model, the images of the numbers and tell the machine which image is of which number and let it differentiate on its own. This would use the backpropagation algorithm, and the machine would make its best guess using numerical inputs and mathematical equations. But when it gets the incorrect output, it would change its inner workings to try to not make the same mistake again. This changes in the prior inner workings is what we call backpropagation. This is the simplest explanation of how backpropagation works. There is a lot of complex mathematics to try to imitate a neuron, which is the most basic cell in the human brain. But how exactly does this all work together? Let's say input is given to a machine. Now imagine the machine having layers, where each layer is modified all the inputs in some way. How much a layer modifies the input, and if it modifies each input differently, is decided by a concept called weights. How much the layer will modify the input is called the weight, and these weights are the values which are tweaked by backpropagation. Each layer applies mathematical equations on the input and repeats the process multiple times, apparently thousands of times, to generate a probability for each output, and the highest probability is the number that is chosen by the machine. Every time the generated output is compared with the actual output, the weights are changed according to how much the difference is between the actual output and the generated output. For example, going back to the digit recognition, if a machine predicts an actual 7 to be a 9, there is a big change in the weights because a 7 is not like a 9. But if the machine predicts an actual 7 to be a 1, that is a much closer prediction and a small change is made to the weight. Repeating this process several thousands of times is how backpropagation trains a machine learning model. So, in conclusion, I would like to summarize: machine learning takes input and output to generate the instructions to arrive at the output, and at the basis of everything is data. So, be it using data sciences, analytics, engineering, or even simple visualization, good quality data will always result in good quality machine learning. Thank you, AI Cam, for listening to me, and I hope to hear back from you very soon. Looking forward to talking to you in person. Thank you.